Hello everyone, how are you? My name is Prakhar Shrivastava and I welcome you to Complete Calculus Series 7 hours masterclass. This masterclass is not in one class, 10 minutes videos are there and I hope that you will enjoy today's videos as well. But I'll just brief you about myself. I have secured All India third rank in GATE 2000, took admission into IIT Bombay, IIT Kgp, but finally completed my masters from NITIE Mumbai, which is one of the top-notch institute for supply chain management in India. Currently, I carry an experience of teaching for about 6+ years now, and I have taught more than 25,000 students who are placed in top-notch firms of India and after studying from reputed colleges of India. So if you want to know more about me, you can obviously reach out to me on my Telegram channel, Maths Confidence. And yes, I also carry a corporate experience for working with the top-notch brands of India and international. Okay, so I hope that you have got a brief idea about your faculty. Currently we are discussing the topic of calculus. And in the previous lecture we have discussed about the small topics of calculus earlier as well. Okay, so let's go. Okay, so now we have to understand about the limits. So the first topic in calculus is limit. Sir, what do you mean by limits and why we need to study limits? See, calculus is all about integration and differentiation, but integration and differentiation also depends upon the value of function. So suppose you need to integrate a function from, suppose say, this value to this value. Obviously you are going to find out the area in between, we all know that. But what is the value of function at this point and what is the value of function at this point? This is very, very important. So limits actually tell you the value of a function at a particular point. Suppose I tell you that 1 upon x square integrate between -1 to 1. Now you will simply apply the formula and integrate it, but that will be wrong. Why? Because in this range -1 to 1, there will be a point where x will be equal to 0, and when x is equal to 0, the function becomes not defined, so you cannot integrate it. So if you need to integrate or differentiate something, you need to find that whether that function exists at that point or not, and that is what do you mean by limit. That is what do you mean by limits. I hope that this is clear to you. Just a second. So that is why studying limit is very important, that whether a function exists at that particular point or not. Without wasting any time, let us move forward. So what do you mean by limit? A limit is the value of a function approaches as the input value gets closer to a specified quantity. So suppose x is approaching 0. Now, very important, if x is approaching 0, x can be minus 0.0001. At this point, minus 0.0001, this function will not be defined, it will be defined, and just after 0, that is at 0.0001, again the function will become defined. Is it clear? So that is why as x is approaching 0, the function is approaching a not defined value. Is it clear? And limit, once you are done with the limits, then limit is used to check whether the function is continuous or not, derivatives, integrals, everything in calculus revolve around limit, but we don't value limit. We think limit is a very small topic in calculus, but believe me, limit is the base of calculus, because if you don't know the limit or the value of a function at particular point, how can you differentiate, how can you integrate? So how to calculate limit? So there are two methods of calculating limit. First is analytical and second one is graphical. Analytical limit calculation is very easy thing. I don't think that this is a very difficult task. For example, the first method in analytical is direct substitution. I'll take you. So see, if you need to check what is the value as x tends to 2, what is this value of a function? So if you put x is equal to 2, you will get the value as 10 by 9. So when x will be touching 2, the value of the function will be touching 9. But if I take again my example, classic example, here if x is touching 0, y will become not defined. Y will become not defined. So that is why the first approach to calculate limit is very clear. Directly put the value. Directly put the value. But now many a times the result after applying the value comes out to be divided by 0, infinite by infinity, okay, 0 by 0. So absurd result comes out just by directly putting the value. So in this case, you can simplify the equation. In this case, you can simplify the equation and then put the value. You can factorize it and then put the value. You can factorize it and then put the value. It might be possible that after simplifying it, factorizing it, or you can say rationalizing it. So these are some of the method which helps us to get rid of these situations. But there is another method you will learn about it, L'Hospital rule. But the thing is, you try to put in the value. As soon as you put in the value, you get a valid result. Your limit is over. That is your limit. But suppose after filling in, you get absurd result. Then you try to revamp the equation and then try to apply it. You try to revamp the equation and then try to apply it. Is it clear? But like suppose normal n by infinity, infinity by n, like there are some absurd results. Is it clear? So now the second method how we can apply. So I will just take you to a blank page and I will explain you how the limit thing works. I'll just explain you how the limit works. How the limit works. This is very important for you to, this is very important for you to understand. Suppose this is your graph. Now at x is equal to a, I will try to find out the limit. But when I am trying to find out the limit, I am getting absurd result. So now let us move to this point. Suppose 1 upon x square. Now if I take a value, suppose this equation is, the equation is this 1 upon x minus a, suppose. Now if I put x is equal to a, the value of the function will become 1 upon 0. So what I will do, I will take just a left value of a value just to the left of a. You can consider it to be 0.9999a. Okay, and I will try to find out the result at this point. If you try to find out the result at this point, there will be a result because x will be 0.9999a. So the denominator will not become 0. So this value is equal to left hand limit. Similarly, you will try to calculate the value just right of it. So this will become right hand limit. Now what is left hand limit? As x is approaching a from the left hand side, the value of the function is approaching LHL from the left hand side. समझ में आया? अगर x a बनने की कोशिश करेगा तो जो फंक्शन है ना वो LHL बनने की कोशिश करेगा. Is it clear? Similarly, अगर x राइट से a बनने की कोशिश करेगा तो जो फंक्शन है ना वो राइट से RHL बनने की कोशिश करेगा. Now if both the values are coming to a same point, मतलब if LHL is equal to RHL, we say that limit exists. 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 I don't think that this is a very big problem to you. I don't think this is a very big problem to you. This is crystal clear, absolutely easy thing. That is, the function is approaching, the function is approaching. If both are converging at the same point, means limit exists. Means limit exists. Now one is approaching from left hand side, it is approaching like this. From right hand side, it is approaching like this. Means the limit does not exist because left hand limit is lower, right hand limit is upper. And obviously you can see that there is a gap. So that is why the first step is direct substitution. The second step is LHL and RHL. I'll directly go to the graph. See. When you see here at 3, the value of the function that is approaching from left hand is 2. That is LHL is equal to 2. But just right of 3, if you try to approach the graph from the right hand side, you will reach to a value RHL at 3 will be equal to 1. RHL आप आए यहाँ पर and you converge at 1. This point is 1 ना, and but if you try to approach from left hand side, you are converging at 2. So obviously left hand limit is not equal to right hand limit, and it is clearly visible in graph as well. So at 3, if I ask you what is the value of the function at 3, you don't know. It is not 1, it is not 2. Just to the left of 3 it is 2, just to the right of 3 it is 1. Just to the left of 3 it is 2, just to the right of 3 it is 1. But believe me what I am trying to say, that at 3 you cannot define a function. So we will say that limit does not exist. Limit does not exist. Why limit does not exist? Because the value of the function cannot be defined at that point. I hope you are getting my point. Is it clear? So that is why this is the basics of limits. This is the basic of limits. Okay, so the next topic that we are going to discuss now is continuity. What do you mean by continuity? I will explain you a bit before we move forward. So suppose this is your graph. Suppose this yellow one is your graph. Now, till now we have understood, suppose this is a point A. Now, whether limit exists at this point or not, how we calculate? First attempt is that we will try to calculate f of A. That is, the function is defined at A and there will be a particular value at A. Now suppose we aren't able to calculate this. Then what is the next approach? We have understood this also till now. That is, we'll take a value just smaller than S, or you can say 0.9999A, just a value left to A. Okay? We'll calculate the value of the function at this point. Now I'll explain you. Suppose your function is, we have already discussed this, suppose your function is x square divided by x minus a. Now if you put the value of x is equal to a here, this function will go something like divided by 0, which is not acceptable. Now what you are going to do, you are going to calculate the limit just left of a. Now if you put x is equal to 0.99a, your denominator will not be reduced to 0. Similarly, if you take a value just right of a, it can be anything. I am just assuming that it is just a bigger value than a. So this will be somewhere like 1.0001a, suppose. Now we know that there is a value at this point. So this is called as left hand limit. This is called as right hand limit. We have already discussed this. Now if you want to know that whether limit exists or not, so first of all you will calculate f of a. If f of a comes out directly by direct substitution of a, means that limit exists. Secondly, you try to solve it using factorization, rationalization, L'Hospital rule. We have seen everything. But still, if you are not able to get the value of f of a, okay, when x is tending to a, what is the value of function? If you are not able to get it, we go to the second approach. That is, we'll calculate left hand limit, we'll calculate right hand limit, and if both of them are equal, we will say limit exists. So these are the only two methods with the help of which we can say that limit exists or not. Okay, so this is what we are doing. Now what we are doing, we have explained, I have already explained to you this in the last lecture. Suppose, what do you mean by left hand limit? Left hand limit is that value that the function is bringing while x is moving towards a. So जैसे जैसे x a बनेगा, as soon as x is getting converted to a, the value of the function will also get converted to the same value. So whatever we are calculating at LHL, left hand limit, is nothing but what is the function, what is the value of the function at this point, and it will be very smallly there will be a very small difference as soon as we move from 0.9999a to a. Now this difference can be huge also. But now second thing what we are calculating is right hand limit. That is, what is the value of the function? ये function की क्या value लेके आ रहा है if we are approaching from right hand side? Suppose we are approaching from right hand side. Suppose we are approaching from right hand side. What is the value? That is right hand limit. Suppose we are approaching from the left hand side. What is the value? That is left hand limit. Now, if the two values are equal, that is, this is your left hand limit and this is your right hand limit. Now, we say that left hand limit is defined, right hand limit is defined. So the value in between will also be defined. Okay, this means limit exists. Now, if we fill the in between, if we know the in between value also, that is the value of actual value of f of a, can we say that, or and if it is equal to left hand limit and right hand limit, and these are so close, these 3 points are so close to each other that they assume to be line, a continuous line. So that is why, what do you mean by continuity? It is equal to left hand limit is equal to value of the function at that point is equal to right hand limit. So this is the formula that we will be using for continuity. This is the formula that we will be using for continuity. This is the formula that we will be using for continuity. ठीक है? But why this formula works? Because अगर आपकी left hand limit ये है, suppose ये y x है, ये आपकी पहली blue dot is your left hand limit, your green dot is the value of f of a. Now it is equal to left hand limit only, and this is equal to right hand limit. Now if the three dots are very close to each other, can you say it is a line? Yes. So that is why a graph becomes like this. Okay, so in a continuous graph, at any point the value of the function will be equal to its left hand limit and its right hand limit. Is it clear कि left से जो function की value है, right से जो function की value आ रही है, और उस point पे जो function की value है. What do you mean by that? That is this formula. So I hope that continuity is clear, and why this formula is used in continuity. So we'll see something formal. So what do you mean by continuity? We are still concerned with the limit of f of x as x approaches a, but a new number is involved, that is the number f of a. Okay. Now this is the value of the function at x is equal to a. For a limit x approached a but never reached it. So x is tending to a, x is trying to reach to a. So what is the value of the function will try to reach? That is f of a. Simple. We are calculating this. Is it clear? So what we have calculated till now, LHL, is what is the value of the function when x is approaching to a. What is the value of the function from the left hand side when x is approaching a? RHL. What is the value of the function if the function is reaching from the right hand side? Is it clear? तो हम मतलब बोलते हैं ना that 1.001a, 1.002a पे we'll calculate the value, 1.001a पे we'll calculate the value, 1.0005a पे we'll calculate the value. So what is the value of the function? If the two values are equal, that limit exists, and if it is equal to y of f of a, then the function is continuous. So if we actually see, if a function needs to be continuous at any point, it has to qualify for three conditions. First, the number f of a should exist, the limit of f of x exists, that is left hand limit should be equal to right hand limit. Okay, and finally f of a should be equal to left hand limit is equal to right hand limit. So as soon as the x is trying to become a, it has not become a, the value of the function will become f of a. Is it clear? So that is why if the 3 points are equal, 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 we will say that the function is continuous. So I hope till now you have got the value how you prove a function to be continuous. You calculate its left hand limit, its right hand limit, its value at that particular point, and you equate all the threes. That is a very, very simple thing. I don't think that this is a very big issue. Is it clear? So we'll start with types of discontinuity. Okay, so the next topic that we are going to discuss is types of discontinuity. So before we move forward, I would like to tell you that in previous topics we have covered what is continuity, what are limits, and we have also seen what do you mean by continuity. So I'll just revise a bit, that if your left hand limit is equal to the value of the function at that point and it is equal to right hand limit, we'll say that all the 3 points are equal and they are so close that a small line appears. So that is why when all the small lines joined up, so it forms to be a continuous graph. But there might be a discontinuity in this. For example, at this point, it might be possible that there is a discontinuity at this point. It might be possible that there is a discontinuity at this point. So it might be possible that there is a discontinuity at this point. Okay. But now what are the different types of discontinuity? I am going to discuss about them. So let us check back. There are 4 graphs and I will be discussing about the 4 types of discontinuities. There are 4 graphs and I will be discussing about the 4 types of discontinuities. I hope all the 4 graphs are like clear to you. Okay. Anyways, now in the first graph, it is visible to you that there is a straight line but a small gap at this point. Okay. So this is the first type of discontinuity. In the second graph, your function goes like this till 0, and as soon as the value of x go beyond 0, the value of the function becomes 1. This is type of electrical signal. Here you can see in the third case, as soon as the value of x is approaching 0, the value of the function is going towards infinity. Similarly, as soon as the value of x is approaching 0 from the positive side, again the value of the function is going to infinity. So they might meet at infinity, but there is no such value. So they will meet at infinity, so practically they will never meet. So if they can never meet, so that is why what do you mean by this? This clearly shows that it is a sign of discontinuity. It is a sign of discontinuity. I'll tell you about a small rule about continuity. If without lifting pen you can draw the graph, it is continuous. Without lifting pen you can draw the graph. You can draw the graph that is clearly continuous. That is clearly continuous. And in the fourth case we are seeing, there is a patch, this white color patch. I hope now it is visible to you. This white color patch just behind me. Now in this patch you can see the function is not defined. Okay. For example, if f of x is sine 1 by x, then there will be a discontinuity. Now there are basically 4 types of discontinuity. So if I actually tell you about the first figure, this is figure 2.20. Okay. So now if I actually discuss about the first figure, so it will be basically your function is not defined at 0. So if x is equal to 0, you don't know what is the value of function. If x is equal to 0, you don't know the value of function. If x is equal to 0, you don't know the value of function. Okay, you don't know the value of function. So now this is just a point. This is just a point where the value of function is not defined. If I define the value of function at this point, don't you think that this discontinuity will be removed? Yes, if I define the function at this point, the discontinuity that we are going to discussing right now, it will be removed. So that is why when only one point is missing, we will say that it is a removable discontinuity. Why? Because we just need to define this function. We just need to define this function at this particular point. And we know we can define it. That's not a very big deal. If we can write f of 0 is equal to 0, if we can make the graph as f of 0 is equal to 0, automatically the graph become continuous. But in second case, if I say x is equal to 0, at x is equal to 0, what is the value of function? You cannot tell me the value because it might be 0, it might be 0, between 0 and 1. It can be any value between 0 and 1. It can be any value between 0 and 1. If I ask you x is equal to 0, what is the value of y or what is the value of u? Here the function is u. So at sir x 0 dikh raha hai, but after x it is 1. before x it is 0. So can you say that there is a huge discontinuity at x is equal to 0? There is a huge discontinuity at x is equal to 0. There are multiple values. There are multiple values of a function at a point. So that is why there might be multiple values. Okay, so that is why we will say that this is a jump discontinuity. Suddenly the graph jumped from one point to another. So this is a jumped discontinuity and it cannot be removed because you cannot define at x. Here we can say if f of 0 is equal to 0, we have defined it, so the continuity is removed. But here if you define f of 0 is equal to 0, still there will be continuity. If you define f of 0 is equal to 1, still there will be discontinuity. So jump discontinuity cannot be removed, whereas in the first case that the discontinuity can be removed. Whereas in the third case, if you talk about, so I'll just go through the formal definitions. If you want these slides, you can get them in my group Maths A Confidence on Telegram. Maths A Confidence. My approach is to boost your morale. Okay. Now it's very clear. If f of x is a step function, that is, it is varying between 0 and 1. So before x is equal to 0, the value of the function is 0. As soon as the value of x crosses 0, the value of the function becomes 1. Okay, and such type of discontinuity is known as jump discontinuity. In the third case, where the value of the function is 1 upon x square, we know that the graph goes to infinity. Now one very small thing I have already discussed. What do you mean by infinity? Infinity is nothing but a very high number. Very high number. Is it clear? Because there is no end to number. So anything which is very high, we term it as infinity. So if you check back in this graph, the graph goes to infinity and meet. The graph goes to infinity and meet. That's all what is written here. That's all what is written here. Is it clear? So that is why in the graph of 1 upon x square, the only reasonable limit is L tends to infinity. Okay. At x is equal to 0, L tends to infinity. It cannot go on record as saying this limit exists. Officially it doesn't. Ab infinity to koi limit nahi hoti hai na. But we know that somewhere it will go and meet. Is it clear? And the last type of discontinuity is known as oscillation discontinuity. So at x is equal to 0, the value of sine 1 by x, at x is equal to 0, the value of sine 1 by x is not defined. So that is why we cannot put any value of y at x is equal to 0. So can we say, and this is repeated again and again. This is repeated again and again. As you can clearly see here, it goes and then repeated and then repeated and then it goes and then it get repeated. Is it clear? So these are the 4 types of discontinuities: oscillatory discontinuity, infinite discontinuity, jump discontinuity and removable discontinuity. All the 4 discontinuities we have studied. Chalo, let us move to the next topic. The next topic that we are going to discuss is the pinching theorem. What do you mean by pinching theorem and where pinching theorem is used? देखिए, many a times you are not able to calculate the value of limit. Many a times you are not able to calculate the value of limit. Either you are not getting the value by direct substitution, or you are not even getting the value as LHL is equal to RHL, because you are not able to calculate LHL and RHL. And sometimes the problem becomes too tough and lengthy if you try to calculate the limit. So there is a small solution. I will tell you that small solution. Suppose there is a function x, g of x and h of x. We know if limit x tends to a, f of x is equal to limit x tends to a, h of x is equal to L. Okay. And we also know that f of x is less than g of x is less than h of x. So if the limit of two values, if the limit of the extreme functions are approaching L as the value of x is approaching a, don't you think that if the lower value and the lower function and the upper function both are approaching the same value L if x is approaching a, so this should be valid for g as well. So that is why limit x tends to a, g of x will also be L. So now many a times our function is g of x and we cannot calculate the value of L in one go. So what you will do, you will find a function which is less than that, you will try to find a function which is greater than that. If both the functions are converging to the same value L, it means that g of x will also converge to L. I hope that this is clear. Let us see this formally. If f of x is less than equal to g of x, is greater than equal to g of x, and less than equal to h of x for all x, so we know that limit g of x tending to a is equal to limit of h of x tending to a is equal to L. Then the value of the function will also be equal to L if x is tending to a. For example, हम एक question करके देखते हैं इसका, ठीक है? So you need to calculate the value of limit n factorial by n to the power n if x is tending to infinity. If you try to solve this question directly in one method, you won't be able to solve. You will not be able to solve because there are lots of things in this, okay, and you cannot apply directly. So if you try to calculate the value, still you won't be able to get the value of f of a. So what you will do, you will find a function greater than this and you will find a function less than this. For example, this can be written as n factorial by n to the power n can be written as n by n. Now n factorial can be written as n into n minus 1 into n minus 2 up to 1, and denominator n to the power n is n n n n n. Now we know this is 1, this is something less than 1, this is something less than 1, yes or no? Obviously yes. So this whole value will be, if I write it as 1, this value n by n is 1 into 1. If I write this value is less than 1, you again multiply 1, so this value is also less than 1. So this whole function will be less than 1 into 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 1 by n. Last value is written as 1 by n only, okay? And it is very clear, okay? Now it is very clear. We know very simply, we know very clearly that n factorial by n to the power n is greater than equal to 0, okay? Is greater than equal to 0. So if you try to solve it in, and if you see the right hand thing, so it is greater than 0 and this same value is less than 1 by n because this whole function is less than 1 by n, yes or no? So if you try to calculate this value, it will be more than 0 and less than 1 by n. So we know the limit, that the lower, that function in our case f of x becomes 0 and h of x is 1 by n. Now we know if n tends to infinity, this will be equal to 0. So can you say n factorial by n to the power n is greater than equal to 0, is less than equal to 0 if the limit n tends to infinity? So can't you say that the value of this function will also be equal to 0? Can't you say that the value of this function will also be equal to 0? Can't you say that the value of this function will be equal to 0? Obviously you can say that. So that is why this is a sample of pinching theorem. Pinching theorem is nothing but a way to make the problem easier for you. Many a time it is not possible for us to calculate a value. So what we will do, we know its lower limit, we know its upper limit. So if both the lower and the upper limits are equal, so automatically the value that is in between will also become to that equal value. The कितना simple logic है ना ये. So this is thing. So if you want this slide, you can get them in Maths से Confidence Telegram group. Okay. Pinching theorem, I don't think that you would be having any difficulty. I have explained you the pinching theorem. Similarly, I have explained you the pinching theorem with an example. Okay. Chalo. So the next topic that we are going to discuss about is differentiability. Till now we have discussed about the limit. We have also discussed about the continuity part. And now it is time to discuss differentiability. I'll just give you a brief idea. I'm not going to discuss about the derivatives right now. I'll just give you a brief idea because I know derivatives are something that you are able to solve. So I'm not going to focus on derivatives a lot. I'll take the derivatives at the end. That is not a problem. After differentiability, we'll directly move to Leibniz equation, chain rule, implicit functions, and how to solve different kind of derivation, like differentiation. But I'll not go into the basics of differentiation, that this, the differentiation of x to the power n, x to the power n is this and that. No, I'm not going to do that. I'm not going to do that at all. I hope that I'm clear till this part. I hope that I'm crystal clear till this part. Okay, sir. कोई दिक्कत, कोई भी दिक्कत नहीं. So now what you're going to do? So now what you're going to do? Differentiability. So now you know limit. Now you know what do you mean by limit. So the value of a function at a particular point. Value of a function at a particular point. That suppose this is x is equal to a. Whether the function is defined at x is equal to a or not, that is told by limit. Now, whether this function is connected to the right and the left value of the function or not, that is told by continuity. Now, since the point is defined, the next and the backward point is defined, so now we can perform the differentiation, because suppose this is point A, so this is something more, something next to A, like see, this is at x is equal to a, the value of the function. This is something more than a, this is something less than a. But I have defined both the left and right points. Now if I want to find out the differentiation, see, differentiation is dy by dx only, and that is y2 minus y1 divided by x2 minus x1. But for this you need y2, y1 and x2 and x1. I hope you are getting my point. I hope you are getting my point. So you need y2, you need y1, you need x2, you need x1. Is it clear to you? Is this thing clear to you? If it is clear to you, you understand that you require the points, you require the next and the previous points, then only you will be able to calculate the difference. Now, then only you will be calculate the, then only you will be able to calculate the difference. Na macha. See, good. Now, what is LHD and what is RHD? Differentiation, I'm telling you. See, after this, I'll directly jump to chain rule and Leibniz equation after this topic. I'll not enter into the basics of differentiation and all. I know you all know that, and this is a very crucial period. Na? Suppose you need to differentiate the function at this point. So you need to draw a tangent at this point. This is what you mean by differentiation. Now, if you need to draw the tangent, I'll zoom it up. I'll zoom it up for you. Suppose you need to calculate the differentiation at this point. So now there will be a left hand derivative, that is you will take a left point and this, and you will try to calculate the differentiation with respect to the previous point. So this is your left hand derivative. Similarly, you will take a right hand point and you will try to find out, this will be your y2, this will be your y1, but in previous case this is your y2, this is your y1. Is it clear? So this is nothing but right hand derivative, right hand derivative, right hand derivative. So what you are doing right now, you are calculating the differentiation of that point with respect to previous point, and in RHD you are finding the difference in the values of that point with respect to the next point. If these two values are equal, means the slope of this and the slope of this are equal, can you say that this acts as a straight line and that acts as a tangent? For example, suppose this is the point. Now if I want to check the derivative at this point, now the derivative with respect to previous point will go like this, whereas the derivative with respect to next point will go like this. So both the derivatives, the direction of both the lines are different, whereas in this case the direction of both the lines are same. I hope you are getting my point. So the function is not differentiable at this point. So that is why whenever there is a notch, now we say that the function is not differentiable, that this function is not differentiable. Is it clear? So whenever there is a notch, because at notch the tangent changes its direction, so that is why the left hand derivative and the right hand derivative should be the left hand derivative and the right hand derivative should be equal, because this is highly required. I hope this is clear to you. I hope this is clear to you. I hope this is clear to you. ठीक है, तो दिस इज द बेसिक. नाउ देखो, डिफरेंशिएशन इंटीग्रेशन में इस कॉन्सेप्ट की जरूरत नहीं पड़ेगी, बट दिस इज एक्चुअली समथिंग दैट हेल्प्स यू टू क्लैरिफाई व्हाट इज हैपनिंग. सपोज आई नीड टू डिफरेंशिएट अ फंक्शन एट दिस पॉइंट. Suppose I need to differentiate a function at this point, so I need to draw a tangent at this point. But to draw a tangent, I need the previous and the next point if you logically see. So that is why it is very important for you to understand. If you are not able to understand, please be relaxed. You are not going to face any difficulty while solving the problems. But this actually helps you to clarify, and it is not possible to understand in the first go. Okay. In the next lecture, we will start with the Leibniz theorem then. So the next topic that we are going to discuss is Leibniz theorem. But why Leibniz theorem is used? What in which type of questions we will be using Leibniz theorem? What is Leibniz theorem? And can you solve an example of Leibniz theorem? All these questions are to be asked, are to be solved in upcoming 10 minutes. So first we'll understand what is Leibniz theorem. So if you actually dig deep into the definition aspect, so many a times we need to calculate the first derivative, many a times we need to calculate the second derivative, and similarly third, fourth, and go on, and it goes on. So if you actually check back, if we are having a formula of nth derivative, if we are automatically having a formula for nth derivative, we can very easily find all the derivatives just by finding out the formula for nth derivative. Yes or no? So that is why Leibniz theorem is used. Leibniz theorem is used to find the nth derivative of the multiplication of the two functions. Okay, so now suppose the two functions are u and v, and if we need to calculate the nth derivative of this function, now what will be the formula? Nth derivative of the function u into the first derivative of the function v, nc1, n minus 1 derivative of the u function, and the first, sorry, here you don't have the first derivative, it is directly the function v. Here you are having the first derivative of the function. We'll see the example, everything will be clear, but please try to understand. Here the derivative of u is decreasing, whereas the derivative of v is increasing as we are moving ahead. And what is the one value that is coming in? nc1, nc2, nc3, and it goes on. So if you need to find the nth derivative, you have to add all the terms, and the last term will be ncn u vn. That is, take the original function u into the nth derivative of v. If you are doing this, automatically you can find the nth derivative of the multiplication of two functions u and v. इसके बाद आपको कुछ भी करने की जरूरत नहीं है. Now if you need to find the first derivative, you put the value of n is 1. If you need to find the sixth derivative, you put the value of n is 6. You need not to find derivative again and again and again. You will find a general equation of derivative, and this is very important from the exam, any exam perspective. Let us see a question. Suppose you need to calculate the nth derivative of e to the power x 2x plus 3 the whole cube. Now this is your first function, that is e to the power x, and this is my second function, that is v. Is it clear? So u is e to the power x, v is 2x plus 3 the whole cube. Not a very big deal, very simple thing. Yes sir, absolutely clear. Now any derivative of u will be equal to e to the power x, whether it is u1, u2, u3, u4, because the derivation of e to the power x, the derivative of e to the power x is e to the power x, then again the second derivative will be e to the power x. Yes or no? Similarly, we'll calculate all the derivatives of v if possible. So v1 is, that is the first derivative is, so 2x plus 3 the whole cube, 2x plus 3 the whole cube. If you actually like differentiate it, it will be equal to 3 2x plus 3 the whole square into the differentiation of 2x is 2. So the answer will be 6 2x plus 3 the whole square. That is the first derivative. We again differentiate it to find the second derivative. So this will be 12x. Okay, sorry, not 12x is square. So 6 is 6. 2x plus 3 the whole square ka differentiation will be 2 in front, 2x plus 3 to the power 1 into 2, the differentiation of 2x. We have learned this in chain rule. Yes or no? I'll explain this to you, not a big. So what is the derivation of this? 6 into 2 into 2x plus 3 into 2x का differentiation is 2. So when you will solve, you will get 24 2x plus 3. Again you differentiate it, you get 48. Now beyond v3, that is after the third derivative of the function v, all further derivatives will be equal to 0. All further derivatives will be equal to 0. Now by Leibniz theorem we know, I hope that this is clearly visible to you. By Leibniz theorem we know u into v, the nth derivative of u into v is equal to nth derivative of u into the function v, nc1 n minus 1 derivative of u and the first derivative of v, and it goes on and on and on. It goes on and on and on. So I hope that this is clear. So we have understood the formula for Leibniz theorem. We'll solve this question for now. We have to calculate the nth derivative of this term. Okay, u, this is un, and this is what? V. Now this is nc1, nc1 is n, this is u n minus 1, okay, that is any derivative of u will be e to the power x, and this is v1. Similarly we'll apply, this is nc2, this is u n minus 2, that is the n minus 2th derivative of the u term. जो u term है ना उसका n minus 1 derivative, अब कोई भी derivative हो ये e to the power x ही रहेगा, and here we are increasing, so here v1, so here you will be having the second derivative of v, okay, and second derivative of v, and similarly this will be nc3 u to the power n minus 3, that is the n minus 3th derivative, or this is v4. Now beyond v4 all the values are 0, so we are not writing, we will simplify it, and this is the value of the function of the nth derivative of this value. Okay, the nth derivative of v is not possible after the fourth term, but yes, nth derivative of u into v is possible. And now suppose you need to find out the sixth derivative of this function. You need to find out the sixth derivative of this function. What you will do? E to the power x 2x plus 3 the whole cube plus 6 into n की value is 6, so 36, 2x plus 3 the whole square plus 72 into 5 into 2x plus 3 plus 8 into 6 is 48, 5, 4. So this will be the value of nth derivative of this function. We have calculated it within a minute. But how we have calculated it? Because we have a general formula for nth derivative for the multiplication of two functions. I hope that this is crystal clear to you. This is Leibniz theorem from my side. If you are having any doubt, please let me know in the comment section, because this is easy, this is not tough, and it is very useful in many cases, because for higher order derivatives you don't have to go again and again and again and again. That is the beauty of Leibniz theorem. Okay, so guys, the next thing we are going to discuss about is the chain rule. But why chain rule is used? What is chain rule and how we need to solve the question? So suppose you need to differentiate x square. The differentiation of x square, that is d by dx with respect to x, this will be equal to 2x. Now if I am saying that you have to differentiate what? You have to differentiate x to the power 2 nahi, x to the power sin x. Now what will be the differentiation of x to the power sin x? Now first you need to treat sin x as a constant, and then you need to differentiate sin x in the multiplication. So we will treat sin x as a constant. So this will be equal to sin x, x to the power sin x minus 1. But you will multiply what? Till now you have considered sin x as a constant, but sin x is not a constant. Sin x is having the term x, and which itself is a variable. So when x changes, sin x changes. So how can you treat sin x as a constant? So you first treated sin x as a constant, but then you need to differentiate sin x separately. So the differentiation of sin x will be equal to cos x, and hence this will be your answer. So what we did, we first treated the variable as constant and then multiplied the differentiation of that variable in the whole equation. We'll see, for example, you have to find the derivative of this. Now very important, first we will treat this as what? First we will treat this as what? ये क्या है? This is nothing but a function. So if h of x is given as 1 upon g of x the whole square. Can I write it in this manner? Because g of x is 3x square plus 1 the whole square. Now you will differentiate this function keeping gx as constant, and then you will multiply this with the differentiation of gx, and then you multiply this, and then you multiply this with the differentiation of gx. Is it clear? So what we are assuming here, very very important. So this is nothing but 3x square plus 1 to the power minus 2. We differentiate it. So this is equal to minus 2 comes in front, 3x square plus 1 to the power minus 2 minus 1 hota hai na, so minus 2 minus 1 is minus 3. Now you have considered this as a constant, as a normal value, okay, as a single variable. So now 3x square plus 1 will again be differentiated, and what will be the differentiation of 3x square plus 1? It is equal to 6x, that is 2 into 3 is 6, okay, 6, and x to the power 2 minus 1 is x, okay. So that is why now the differentiation of h of x is minus 2 3x square plus 1 to the power minus 3 into 6x. Is it clear? And when you further solve it in a simpler manner, you will get this value. So now the differentiation is not possible directly. So what you are doing, let me tell you what you are doing in this case. You are assuming 3x square plus 1 is equal to z. Okay, not a big deal. You differentiate both the sides. With respect to x. So this will be equal to 6x is equal to dz by dx. I hope this is clear to you. Now when you are performing this, d by dx of 1 by z, you have to multiply. This is dz now, so you have to replace dx by dz. So from here can you say dx is equal to dz by 6x? Yes sir, bilkul sahi, absolutely clear. You put it here, so this will be equal to d by dz of 1 by z into 6x. Now you differentiate, this is very 1 by z square hai, okay, but you can easily differentiate this because now this is a single variable, but automatically a valued multiply is already been mentioned here. So this is what, this is nothing but d by dx of the function that you are considering constant. Is it clear? So chain rule mein kuch nahi karna hai, you have to differentiate it assuming it to be a normal variable, and then you need to again differentiate this function individually and multiply that to the whole answer, I'll explain you once again. I'll explain you in a more better way. I'll explain you in a more better way. देखो, देखिए, suppose your function is x to the power sine of x square. Now you need to differentiate it, that is d by dx of f of x. So what you will do, you will first consider this as a constant. So you will write sine of x square, x to the power sine of x square minus 1 into, you will differentiate this term keeping this function x square as constant. So this will be equal to cos x square, and now you need to differentiate this also, that is x square, so into x, okay, and this will be your solution. So first I hope you get the pattern. Slowly you will get all the values. First differentiate the bigger thing, then smaller, then smaller, then smaller, and multiply everything. This is what is known as chain rule. And directly the question from chain rule will not be asked anywhere. It is just that your conceptual clarity should be there, because now we are going to, as we move ahead in this course, we have to deal with the difficult problems of differentiation and integration, and for that you should know the chain rule. You have to have an idea about the chain rule, because it is very very important. Is it clear? So I hope that I have crystal cleared your doubts as far as the chain rule is concerned. Okay, so now let us move to the next topic of implicit function. I'll give you brief idea about what do you mean by implicit function. When y is clearly expressed in terms of x. Y is clearly expressed in terms of x. This is known as explicit function. This is known as explicit function. Whereas when f of x comma y is equal to 0 is given, that is in a equation x and y cannot be separated to this value, this is known as implicit function. This is known as implicit function. Okay. So when y is equal to x square sin x, when y is on one side and x is on the other side, this is what you mean by explicit function. That is, y is clearly mentioned in the terms of x, but many a times it is not possible to separate y and x, and if you are separating also, it is becoming very complex and it becomes very difficult to separate. So then if function of x comma y is expressed in terms of 0, if function of x comma y is on the one side, you cannot separate it to y is equal to f of x, then such functions are known as implicit functions. Now we know how to differentiate a function y when it is given in terms of x. ये हमें पता है कि हमें y को कैसे differentiate करना है when it is given in terms of x. But how to differentiate such functions when both the functions are mixed and matched? For example, this is your equation. You need to find dy by dx. Now let us try our usual approach. So y will be equal to 25 minus x square root. Now this is again an implicit function in this form, and this is a explicit form, but if you try to differentiate d by dx of y, this will be equal to very difficult thing. This is 1 by 2. Okay, you can write 25 minus x square to the power 1 by 2. So this will be 1 by 2 root over 25 minus x square, because 1 by 2 minus 1 is minus 1 by 2, so it comes to the denominator. 1 by 2 root over 25 minus x square into the differentiation of this value. So 25 differentiation is 0 minus 2x, so this is again minus 2x. This is the answer, minus x divided by 25 minus x. But the problem here is what? But the problem here is you need to understand, this is not the easy form or not the simple form. This is not a dy by dx. Okay, because y here is mentioned implicitly. So what you will do, you will try to differentiate it directly. Now how you differentiate it? D by dx of x square, that is I am differentiating x with respect to dx. So this will be the d by dx of x square plus d by dx of y square, and d by dx of 25 is equal to 0. Now this will directly be converted to d by dx of x square is 2x, but here you cannot write 2y because you are differentiating with respect to x. Here you are differentiating with respect to x, and here you are changing the variable y. So what you do in this term, you write it as this, d by dx of y square into dy divided by dy. Now this dy comes here, this dx goes there. So d by dy of y square is 2y, and here you are left with dy by dx. So whenever you are differentiating with some other variable, then you have to differentiate it normally, but then multiply dy by dx or the variable differentiation of that variable with respect to x. बस यही हमें करना है. That's all what we need to do. D by dx of x square is 2x. D by dx of y square is 2y into dy by dx, and this is equal to 0. From here, can you get the value? Dy by dx is nothing but y by x, and this is the clear-cut value. This is the clear-cut value. Here you need to do very much hodgepodge, roots and calculation, but here you haven't done anything. So whenever you are given an equation, I'll tell you how. Suppose you are given an equation x square plus y square plus 2xy is equal to y, suppose say. Now if you try to differentiate, this is 2x with respect to x, 2x plus 2y dy by dx plus 2, the differentiation of x and y. So keeping x undifferentiated, you differentiate the second function, that is dy by dx, plus y into 1, the differentiation of x with respect to 1 is 1. Is it clear? And this is equal to 1 dy by dx, that is differentiation of y with respect to y is 1, and then you need to multiply dy by dx as well. So now when you will solve this thing, you can automatically get the value of dy by dx. This is nothing but minus 2x minus 2y divided by 2y plus 2x minus 1, 2y plus 2x minus. So this is the differentiation. From here we haven't separated y and x, and still we are able to solve with the dy by dx or the differentiation part. I hope you have got the point that I wanted to convey. I hope that you have got the point that I wanted to convey, how to solve problems related to implicit function. How to solve problems related to implicit function. Is it clear? Now again you can see dy by dx is equal to minus x by y for our case, in our case. So that is why whenever you are provided with a very simple thing, or you can say the very simple thing, or you can say the implicit function, you directly differentiate it. Whenever there is a term of y, you differentiate it normally like x and then multiply dy by dx to it. Why? Because you are differentiating with respect to x and you are differentiating the variable y. आप y को differentiate कर रहे हो x के respect में. This is not possible. You have to differentiate y with respect to y, and then you need to multiply dy by dx. Why we are multiplying dy by dx, that is also clear to you. Is it clear? So we have understood the chain rule. We have also understood the implicit function, how to solve questions related to implicit functions. So I hope these things are clear. If you are having any doubt, comment section में ज़रूर बताइए. And if you want to see my courses, like a lot of my full courses are available. Then apart from that, my Telegram channel is available, Maths A Confidence, MATHS-E-Confidence. So a lot of things are there, lots and lots of things are there. Hope you will enjoy it. Hello everyone. So next thing we are going to discuss about is the linear approximations. So from here we start with the application of derivatives. I've already told you, in application of derivatives we are going to discuss a lot of things, and the first thing is linear approximation. Then we'll move to increasing decreasing function, maxima and minima, then finding the tangents and the normals. So there are multiple applications for derivative. Okay, the first application is linear approximation. It is usually asked in the examination that find the linear approximation of f of x is equal to sin x at x is equal to pi by 3, and use it to approximate the value of sine 62 degree. But what do you mean by linear approximation? How it is calculated? We are going to understand everything in next 10 minutes. So when you see a graph, the graph goes like this. Now we need to approximate the value at x is equal to pi by 3. Now this is 0, this is 90, somewhere this is somewhere pi by 2. Now if you try to draw a line at this point, the equation of this line you need to find out, y is equal to mx plus c. If you get this line, you can get the values of the remaining things. That is, suppose this is 60 degree. This is 60 degree, what you are supposing. This is 60 degree. You need to calculate the value for 62 degree. Now you don't know the value for 62 degree. How you will be finding it? You calculate the value for 60 degree. A linear, you draw a line at 60 degree and you put the value of x as 62 degree in this. So now this is not the exact answer, but just a linear approximation to it. Because if you draw a graph like this, and if you draw a graph like this, and this is your point of 90 degree, this is your point of 90 degree, this is your point of 90 degree. Okay, now the next point of 91 degree will be somewhere here, but it is difficult for us to find the value because this is a curve. So what we are doing, we are not considering this as a curve, we are considering this as a straight line. So if we have the equation of this straight line, and if we change the coordinate of this x from 90 to 91 degree, can we get the value of 91 degree? Yes, but this is not an exact value. Why? Because we are not considering this to be curve. If we consider this to be curve, it becomes difficult for us to calculate the value. But if we are considering it to be linear, equation of a line, we are assuming it to be a straight line. So suppose we are here, and I'll show you on the bigger area. I'll show you in the bigger area. So this is your curve. Now, you know the value at this point. You need to calculate the value at this point. Now, if you actually see, this is a curve. This is a curve, but we are assuming it to be a straight line. That is what the difference is, because the calculation in terms of straight line is easy. If we get the equation of this straight line, we can easily calculate the value of the other points near to this point, this original point, and the value will not be very highly different from the original value. I hope you are getting what I am trying to say. So that is why instead of considering it to be a curve, we are considering it to be a straight line. But in longer duration, suppose one is this and the other one is this. This is your curve. This should be the ideal thing, but you are considering it to be this. So we cannot do this thing, because for when it is high now, when the value is high, the value is too far. So we are linear approximating at 90 degrees, and I am asking you to calculate the value of 108 degrees. It is not possible. That will not be accurate. But yes, if I have linear approximated at 90 degrees, I know the standard result for 90 degree. I know everything about it. So yes, I can predict the value of 88 degree, 89 degree, 91 degree, 92 degree very easily. And these value will be very accurate also, because this curve is approximately a straight line for a very small duration. I hope you have got the physical significance. I hope you have got the physical significance of linear approximation. That is, we are considering it to be a straight line instead of a curve. Now, if it is a straight line, we need to find the equation line. So we note that pi by 3. We note that pi by 3 is in radian, and when you convert it to degree, it is equal to 60 degree. It is equal to 60 degree. When you convert it into degree, it is equal to 60 degree. And using linear approximation, you know that linear approximation L of x is equal to f of x plus f dash x into x minus a. This is a generic formula for linear approximation. This is a generic formula for linear approximation. This is a generic formula for linear approximation. Okay, this is a very generic formula for linear approximation. Okay, not a very big deal. We apply it here also. F of x, in our case, we need to approximate the value at pi by 3. So f of pi by 3 plus f dash of pi by 3 into x minus pi by 3. If you solve it up, f of x is sin x in our case. F of pi by 3 is sin pi by 3, which is nothing but root 3 by 2. Similarly, f dash x is cos x. The f of x is sin x, so then f dash x will be cos x. F dash of pi by 3 will be cos pi by 3, which is equal to 1 by 2. Therefore, the linear approximation of f at pi by 3 is given as, I'll show you the graph as well. So this will be root 3 by 2 plus 1 by 2 into x minus pi by 3. This is the value of linear equation. Now, if you need to calculate the value of 62 degree, you just need to convert 62 degree in terms of radian. So we know how to convert degree to radian. We have to multiply it by pi by 180. So we convert 62 degree to radian, which is 62 pi by 180. We apply 62 pi by 180 to this x, and we get an approximated value of 62 degree. We get an approximated. So function, the value of a function 62 pi by 180 is this sign is not equal to, this is approximately equal to linear approximation, and you get the value as somewhere around 0.88348. So that's what I have told you. If you have approximated the value at this point, you can get the value above. If you try to see whether a point is here or here, it is approximately lying on the same line. But if we consider it to be like a graph, if we consider it to be a curve, it is very difficult for us to calculate, but we can calculate in the straight line. So that's why this part of sine is considered as a straight line, and then we approximate the value near to this point. So I hope you have got the actual meaning of what do you mean by linear approximation, how to solve question related to linear approximation, until which area linear approximation work. You cannot find a very huge value. For example, if you need to calculate the value of this point, it is not possible, because the value that will be given by this line is this, that is point B dash, and we want to calculate the value at point B. So this is a huge gap. But when you are coming close to the point we are approximating, this, the difference or the error, this is the error part, this, the error is minimizing. So for a very short area, this is very short area, this is applicable. There is very small area under which the linear approximation is applicable. I hope you have got this thing. I hope you have understood each and everything, and I hope now you can solve the question related to your linear approximation. So the next topic that we are going to discuss is the increasing and the decreasing function. देखिए क्या होता है, दिस इज वन ऑफ द स्टार मार्क्ड एप्लीकेशन फॉर एप्लीकेशंस ऑफ डेरिवेटिव, जहाँ पे आपको ये फाइंड आउट करना पड़ता है वेदर द फंक्शन इज इंक्रीजिंग, डिक्रीजिंग और कांस्टेंट. Okay, and there is a very such type of problems are quite simple, they are direct, and you know how to solve them, and there are no such you can say special type of problems in this case. So we are going to discuss about this is going to be a bit longer like lengthy session. We are going to discuss about how to find that whether function is increasing or decreasing, what is the physical significance or the graphical significance of increasing and decreasing function, what do you mean by concavity, like convexivity, and point of inflection. These are 6-7 important terms that we are going to discuss in next 10-15 minutes. So when you move ahead, if I'm saying, it's very simple, if I'm saying that this is a graph, okay sir, this is the graph, and the function is drawn like this. Now if I say that, can you please tell me at this point where the function is going? So as we move, as we increase the value of x, the value of the function increases. So that is why if I am increasing x, the value of the function is increasing. Since the value is increasing, we will say that this is an increasing function. And here, suppose you take this point, this is your a point, and this is another point. Suppose this point is m and this point is n. If I calculate the value of y at m, it is higher than the value of y at n. So can you say, if I am increasing the value of x, if I am increasing the value of x and the value of y is decreasing, the value of y is decreasing, can you say that the function is a decreasing function? Okay, so we understood the physical significance, that is with the change in the value of x to like positive, the value of the function is increasing or decreasing. If it is increasing, then the function will be called as increasing function, otherwise it will be called as decreasing. But sir, how we calculate this? From graph it is clearly visible. If you give me a graph, I can clearly tell you now what is an increasing function and what is a decreasing function. But if I am given with a question, or if I am given with a particular function, how to see the function or how to solve the function, or in what manner we will be solving the function, so as to know that whether a function. So now let us dig deep. Suppose this is your graph. Don't see whatever is written on the screen, just focus here. Suppose this is your graph. I have taken 3 points A, B, C. Okay, I have taken 3 points A, B and C. Now please focus. We know that at A the function is increasing, at B the function is constant, at C the function is decreasing. We know, don't look towards D. Graphically, are you clear that why the function is increasing, why it is B, I am saying it is constant, and why at C it is decreasing? Is it clear? क्या आप ये बता सकते हो? Yes or no? I hope that this is clear to you. But the very important part here is that you need to understand that why I am saying it is increasing, decreasing. From the graph it is visible, but how to use it in terms of formula, because you cannot draw another like graph for every other function that you are getting in the question. Now what you will do, if you check back the value of, suppose you draw a tangent at A, it goes like this. If you draw a tangent at B, it goes like this. If you draw a tangent at C, it goes like this. So now we know that tangent shows the direction, whether it is increasing, whether it is constant, or whether it is decreasing. if we can manipulate some values of tangent, if we can find a particular characteristic of a tangent, we will be able to solve this question. Okay sir, definitely. Now can you see that this tangent is making an angle phi with it? Now we know this is acute. If the angle is acute, the tangent is obviously going upwards. If this value of psi is acute, the tangent is going upwards. If the value of psi is equal to 0, means the function is constant. And if the value of psi is obtuse, for example, I'll show you here. Suppose this is your tangent at C. Now this tangent is making an obtuse angle with the x-axis. So that is why if your psi is obtuse, means the function is decreasing. Okay sir, I got this. That if the psi is acute, means if the angle between the tangent and the x-axis is acute, means the function is increasing. If it is 0, the function is constant, and if it is obtuse, then the function is decreasing. Absolutely okay. Now we'll dig it more. What do you mean by sin psi? Can you write it as, if psi is acute, tan psi will be positive? Yes or no? Tan psi will be 0 for constant function, and tan psi will be equal to negative for decreasing. Yes or no? Sir, we got it. Now what do you mean by tan psi? Tan psi is nothing but derivative. So if you find the derivative at that point, you are actually calculating the slope of the tangent. Is it clear? If you calculate the derivative of a function at this point A, it means that you are calculating the slope of the tangent at point A. And if slope is positive, means the function is going up. If slope is negative, means the function is going down. If the slope is 0, means the function is 0. I hope this is clear. So this is how you calculate a function to be increasing function or a decreasing. Suppose you get a function. I'll tell you the process. Okay, we'll solve question also. I'll tell you the process. Suppose you got a function f of x. You find f dash x. If it is positive, if it is greater than 0, it means the function is increasing. If f dash x is equal to 0, means the function is constant, it is not changing. And if f dash x is less than 0, means the function is decreasing. Now can you solve it by seeing the functions? Yes sir, absolutely. Okay, because many a times you see the problem and you realize by seeing the problem graphically, you can easily solve the question. By seeing the problems graphically, you can easily solve the question. But when it comes to the formula part, you have to be clear how you call a problem as an increasing or as a decreasing function. Is it clear? Now let us see what is written here. So if the function y of x, if y increases as x increases, it is called an increasing function. On the contrary, if x increases and y decreases corresponding to it, it is called a decreasing function. ठीक है भाई, कोई दिक्कत नहीं है. Let the tangent at any point on the graph of the function make an angle psi with the x-axis. So you know that tan psi is equal to dy by dx, which is nothing but f dash x, So that is why to understand, if find out the tangent at, if find the f dash x, you will calculate dy by dx, which is nothing but tan psi. And if tan psi is greater than 0, means the function is increasing. If equal to 0, means the function is constant. And if it is if it is more less than 0, it means the function is decreasing. So at any point where the function is increasing, angle psi is acute. At C where the function is decreasing, the angle psi is obtuse. And the function at point B where the function is not changing, angle psi is equal to 0. Okay sir, so that is clear. Till now I know how to calculate the value of an increasing function or the value of the decreasing function. But there is a next type of question that are asked in the exam. What do you mean by concavity, convexivity, and point of inflection? So I'll tell you that what do you mean by this. देखो, if I say if a portion of curve on both sides of a point, suppose this is your point, and if you take the points left and right to it, they are above it, so we will say that this is concaved upwards. This is concaved upwards. So if the portion of the curve on both sides of a point, however small it may be, lies above the tangent, if you draw a tangent here, so this tangent will go like this, so obviously both the points are lying above the tangent, then the curve on both sides concave upwards, okay, concave upwards, where d2y by dx square is positive, ठीक है. तो जब भी कॉन्केव अपवर्ड्स होगा ना, तो आपका d2y by dx square will be positive. So if your d2y by dx square is coming out to be positive, means there is a concavity upwards. If it is coming out to be negative, it does mean by, what does that mean? It is convexivity upwards. It is convex in the upward, that is the function is going like this. Here the function is going like this. So obviously by seeing the graph you can say whether a function is concave upwards or convex upwards. But yes, if you want to solve the equation and find it out, you need to first calculate the dy by dx and then again differentiate to find out d2y by dx square. d2y by dx square. Okay, so concavity you understood, convexivity you understood, and point of inflection also you understood. Suppose d2y by dx square is coming out to be 0. Suppose d2y by dx square is coming out to be 0. Now, now, now what happens? Point of inflection का क्या मतलब है? Suppose your point is this, at which you need to test the concavity or convexivity, and your curve is going like this. If you draw a tangent to this curve, it goes like this. If you draw tangent to this curve, it goes like this. If you draw the tangent to this curve, it will go like this. Okay, and this is your curve. Okay, now if you take two values and both the values are lying on the opposite sides of the tangent, then you say that this is a point of inflection. And how you see a point of inflection in the equation? You do d2y by dx square, you get 0, and if you again differentiate it, d3y by dx cube, then you're not getting the value as 0. So that is why it is very important to check whether it is concave upwards. See, first you should know how to calculate whether a function is increasing or decreasing. That is done by f dash x or dy by dx or the first derivative. But if you need to check whether this function is concave upwards, convex upwards, or there is a point of inflection, then you calculate dy by dx square. If it is coming out to be positive, the function is concave upward. If it is coming out to be negative, it means the function is convex upwards. And if it is coming out to be 0 and the next different derivative is not coming out to be 0, is a point of inflection. I hope I have answered most of the things that you are actually looking out for. What do you mean by concave, convexivity, and the point of inflection? Okay, so I hope that this is clear. If you are having any doubt, please let me know in the comment section. Okay, or you can also join my Telegram group. That is, you can. That's it. So the next topic that we are going to discuss is maxima and minima. Now, what do you mean by maxima? Suppose this is your graph. Suppose this is your graph. Suppose this is your graph. Now, if I ask you, sir, what is the maximum or the minimum points? Can you say, sir, it goes to a maximum value, then drop to a minimum value, then again go to a maximum value, then again drop to a minimum value, then again goes to a maximum value. Now, then again drop to a minimum value. Now, if I ask you one very important thing, that, sir, what is common among all these points? They are maxima or minima. That I know, dude, that I know. But what is the physical thing that is common in all of them? If you try to draw a tangent at this point, they all are parallel to x-axis. Means if you try to draw a tangent at a maxima or a minima, your f dash x would be equal to 0, because the slope, see, if it is x, but if it is parallel to x-axis, if this is parallel to x-axis, its slope will be equal to 0. Its slope is 0. Slope is nothing but f dash x, or you can say dy by dx. Say dy by dx. You can say dy by dx. Is it clear? Is it clear? So that is why one thing that is common at every maxima and every minima is that f dash x is equal to 0. That I understood, that I clearly understood. It is very, very logical and you have explained it very well. But now, sir, how to differentiate between whether it is a maxima or whether it is a minima? When you double differentiate this function, f double dash x, f dash x comes out to be 0. That is fine. But if you find out f double dash x, if it is less than 0, and if it is less than 0, it means, what does that mean? That this is a point of maxima. Now I cannot show you this in this graph because it goes to the 3D part. That is why I'll just tell you the formula, that if f double dash x is less than 0, then this point of x is a maxima, and if f double dash x is greater than 0, means that this is a point of minima. And it might be possible that you are getting f double dash x is equal to 0. Now in this case you cannot do anything. You cannot do anything. Is it clear? You cannot do anything. So that is why we'll try to find out how to solve question. But I hope you have got the gist how a maxima and a minima works. How a maxima or a minima works. So now what is the procedure for finding the maxima and the minima? What is the given condition? Okay. In f of x, find out f of x, f dash x, that is the first derivative of this function, or dy by dx, and equate it to 0. You will be getting some roots, and they are the points where f dash x is 0. But now first of all, it can be a maxima or it can be a minima. But if I tell you this is point A, this is point B, and this is point C, all the 3 points A, B, C, they are maxima. But out of them also, B is known as the absolute maxima, whereas A and C are known as local maxima. Is that clear? Local maxima. So I hope you have got the idea between the absolute maxima and the local maxima. The absolute maxima and the local maxima. I hope you have got this idea. Okay, not a very big deal. This is crystal clear. Okay, sir. Not a problem. Not a problem. Okay, आगे बढ़ते हैं. So you know how to solve a problem. And if f double dash a is negative, means that f is having a maximum value at x is equal. If f double dash a is positive, that means f dash x is having a minima at x is equal to a. At x is equal to a. I hope this is clear to you. आगे बढ़ते हैं भाई. जब इतना clear तो थोड़ा सा और समझ लेते हैं. Now if f double dash of a is coming out to be 0, now what you will do in that case? F double dash x comes out to be 0. If f double dash x comes out to be 0, now what you will be doing in it? If f double dash x comes out to be 0, what you will be doing in it? In that case, you cannot do anything. You know that at x is equal to a, f dash x is equal to 0. Means that either this point will be a maximum point or will be a minimum point. That is checked by second order differentiation. But second order differentiation is coming out to be 0, so nothing is clear. What you can do? You take the value x is equal to a. You take the value x is equal to a plus 1 or anything somewhat greater than a. Okay, but not very greater than a slight value greater than a. And you calculate the value of y at x is equal to a and y is at x is equal to a plus 1. If this is coming out to be more than the previous value, means the function is the minima. This is a condition of minima, that is the older value and the next value is higher. So it is like this. This is x is equal to a and this is x is equal to a plus something. So obviously it is a minima, that is why the right hand value is higher. The right hand values or the left hand value is higher. Is it clear? And if the right and the left hand values are lower, if x is equal to a is this and x is equal to a plus 1 is this, means the value is decreasing. So this is the point of maxima. Is it clear? So what is the complete drill? I have already told you. I'll make you solve some of the very good questions from these topics. Don't worry, and at the end of the sessions we are going to, like, end of the, like, you can say the entire courses, we are going to discuss for about 6-7 hours only the questions that have been asked earlier in the examination. Okay, now if f dash x changes its sign from negative to positive, that means f of x is having a minimum at x is equal to a. This is another approach. You know what is the value of f dash x? You know the value of f dash x, you have already calculated. F double dash x is 0 na, but f dash x is not 0 at a particular point. So if you put the value of here and there, and if the sign is changing from negative to positive, this means that f of x is minimum at x is equal to a. But it doesn't matter, you can put the value and find out. That is the best thing. That is actually the best thing you can do. Okay, and if there is a no change in sign, means that there is not a maximum, neither a maximum value or nor a minimum value. So whatever we calculate, there might be a absolute maxima or a local maxima. The very important thing is that f dash x is equal to 0 for whether it is a maxima or a minima. And second thing is that if you find that whether at a particular point there is a maxima or minima, it is clearly done through f double dash x. That if the f double dash x is negative, means that at that point the value of the function is maximum, and if it is less than, if it is greater than 0, then at that particular point the value of the function is minimum. Is it clear to all of you? I don't think that this is a problem. In the next lecture, we'll after some time we'll start with Rolle's mean value theorem. Okay, I hope you have clearly understood maxima and minima. You know the drill, how to solve and how to get the values. When you will solve more number of questions, you will be in a better place or better understanding of this particular topic. Okay, so the next topic is Rolle's mean value theorem. Okay, ठीक है. तो Rolle's mean value theorem में होता क्या है? It's basically an application of the derivatives, जिसमें ये बोला गया है, suppose this is your graph, and when you try to draw a graph like this, you try to draw a graph like this. अब क्या होगा इसमें? Suppose this is x is equal to a and this is x is equal to b, but you found like you actually find out that the value of f of a is equal to f of b. Okay, fine, that is absolutely clear. And you know that the value of the function f of a into f of b, see, the graph is going up and the graph is coming down. You understand that there will be a point in between. F of a is equal to f of b. Now it is only possible that, देखो या तो a है, अब इसके बाद now after this either the graph will go up or it will go down. If it goes up, it has to come back down for the same value, and if it is going down, suppose this is b and this point is c, this point is c and this point is c. Now you know the value of f of c is also same, but in this case it is going down and it is coming up. So in any case, if the values are equal, it either has to go up and come back down, or it has to go down and come back up. So there will be a change in the direction. First it will increase and then decrease, or it will decrease and then increase. Okay, so there will be a point where the graph changes its direction from increase to decrease or decrease to increase. If you try to draw a tangent at this point, obviously it will be equal to 0. Obviously the slope of the tangent will be equal to 0, because this tangent will be parallel to x-axis, So that is why it is written that if f of a is equal to f of b, then there exists a point C such that f of C is equal to 0. There exists minimum one point. Now see, I say that f of A is equal to f of C. Okay, f of C, that is absolutely fine. Now there will be 2 points. One, this point, suppose let us say M1. This is the second point M2. This is the second point M2. This is the second point M2. Now what is happening? Please try to figure it out. That there exist 2 points M1 and M2 such that f dash of M1 and f dash of M2 is equal to 0. So there will be at least one point, because it has to go up and come down. See, if f of A is equal to f of C, there can be n number of parts like going this and this and this. So many a times you will be having the slope is equal to 0. Many a times you will be having the slope is equal to 0. I hope this is clear to you. I hope this is clear to you. Now if it is a situation, Rolle's mean value theorem states that if if two values are equal, then there exists at least one value such that f dash C is equal to 0. Such that f dash C is equal to 0. Okay, we'll see it in the written forms. That is exactly the theoretical things. So if f of x is continuous, if f of x is continuous in the closed interval a to b, first thing, and f of x exists for every value in x in the open interval, not including a and b. Open interval means we don't include a and b. That's all for now. So that is why if the function is continuous and for every point the function is defined, and if f of a is equal to f of b, then there exists a point f dash c such that there exists a point f dash c such that there exists a point c such that f dash c is equal to 0. I'll tell you why these first two statements are important. Suppose you try to draw a graph. The graph goes like this and it comes back like this. Now this is your point A and this is your point B. You know, if you try to find out f of A is equal to f of B, that is the third condition is satisfied, but the first condition is not satisfied because it is not continuous here. So that is why in this case f dash c, there is no point c such that f dash c is equal to 0, because c is not even defined for the function. So that is why the function has to be continuous. The value between a and b has to exist, and f of a is equal to f of b. If there are these three conditions, then we can say that f dash c is equal, there exists a point f dash c is equal to 0. Now I don't think that this is a big issue. It's a very big issue. I'll just this thing. I'll just shift this graph a bit right so that I can explain you what is happening. What is happening here? In this case, please try to figure it out. This is a graph. This is a point A and this is point B. We know that f of A is equal to f of B. That is absolutely fine. And there exist 3 points, C1, C2 and C3, C or rather C1, C2, anything you can say, where the slope is getting 0. But it doesn't matter. It should be one or more than one. It cannot be possible. If suppose a graph is going like this, how it can, suppose this is a graph. Take a blank page. I'll explain. Suppose this is your graph. Suppose this is point A. Now the value of the function at A is 4. Now if you again have to get a point to have the value 4, either it has to go up and then it has to again come back down to the same level of 4. So that is why it is not possible that if two points A and B, if 2 point A and B, the value of the function at 2 points are equal, it is not possible that it is going ahead upwards only or downwards only. It has to go up and come back down, then only the two values can be equal. So that is why there exists a point C. It can be 1, 2, 3. Now in this case A and B are equal, but it is going like this. It is going like this. Suppose this is A and B. Suppose these are the 2 points A and B. Okay, we know that the value of the function is this and this, but it can go at n number of times. The function can goes like this. The function can go like this. That's not a problem, because at f of A also it is 4, at f of B also it is 4. But there will be multiple times where f dash c will be equal to 0. F dash c means the tangent, the slope of the tangent is 0. Slope of the tangent is 0. The slope of the tangent is 0 when the curve is changing its direction. So that is why the Rolle's theorem states that there exists a point f dash c. Now in examination, how you get the question? You get these three values and you are asked what is the point at which the Rolle's theorem is proved, or find the value of c such that Rolle's theorem is applicable. Find the value of c such that the Rolle's theorem is applicable. Okay, so I hope that I have answered the more or less the very important part of Rolle's theorem, and if it is possible, let us solve a question before moving to the Lagrange's mean value theorem. So suppose let me just check a question. I don't think that this will be a very big question. It is quite an easy question. I have some very good questions. Now you need to find the value of c. Find the value of c such that the function f of x square minus 4x minus 3 between the values 1 and 4 follows Rolle's mean value theorem. Follows Rolle's mean value theorem. Follows Rolle's mean value theorem. Okay. Now if you try to find out what is the value of f of 1, this is equal to 1 minus 4 minus 3, that is minus 6. What is the value of f of 4? So this is equal to 4 square is 16. 16 minus 16. 16 minus 16 is 0 minus 3 is minus 3. In 1 and 4. Rolle's mean value theorem is not even applicable for 1 and 4. Rolle's mean value theorem is not even applicable for 1 and 4. Chalo, I'll change the question. Actually, it's Lagrange's mean value. Sorry guys. Suppose find c such that f of x is equal to x square plus 2 in the interval minus 2 to 2. Minus 2 to 2. Okay, fine sir, absolutely clear, that's not a problem. So you find the value of f of minus 2. This will be equal to minus 2 square plus 2 is 4. What is the value of f of 2? Is also equal to 4. And this function, the first point, it is continuous and defined. So all the three conditions are applicable. We need to find c such that f dash c is equal to 0. Now it is very important. You do f dash x. This is 2x. You put f dash c. This is equal to 2c. And you equate it to 0. You get the value of c is equal to 0. And this is the verification that the value of c, that is between in this range. See, many a times you will get the multiple values of c. But please check that whether that c is lying in between this range or not. Because if it is outside, that is not a proof of Rolle's mean value theorem. The c is lying between a and c. That is a very important part. So I hope that I have answered your question as far as the Rolle's mean value theorem is concerned. Okay, chalo. Okay, so the next topic that I want to discuss is the Lagrange's mean value theorem. We have already discussed about the Rolle's mean value theorem, RMVT, which states that if the function is going up and down, there will be 2 points A and B. There will be 2 points A and B such that the value of the function at both A and B are same. Let us say M. Then there exists a point C such that f dash c is equal to 0, which is fine. But now what happens if A and B are not equal? if A and B are not equal, if A is not equal to B, then your Rolle's mean value theorem will not be applicable. Then your Rolle's mean value theorem won't be applicable. Now, which theorem will be applicable? Lagrange's mean value theorem. Lagrange's mean value theorem is. Let us check. Lagrange's mean value theorem states that if f of x is continuous in the closed interval a to b and f of x exists in the open interval a to b, then there exists a value c in a and b such that f of f dash c is not equal to 0 in this case. It is f of b minus f of a divided by b minus a. So simply we are generalizing a case where the 2 points are there, a and b, the value of the function is different at both the points, which usually happens, and in that case there might exist a point c such that f dash c is equal to f of b minus f of a divided by b minus a. For example, suppose this is your graph. Now this is a point a and this is a point b. At a the value of the function is y1, at b the value of the function is y2. Now if you try to solve it up like this, you can clearly see that this value is equal to y2 minus y1, which is f of b minus f of a, and this value is equal to b minus, and this is equal to f dash c. Yes, this is exactly correct. That's what I'm trying to talk, that f dash c is equal to f of b minus f of a divided by b minus. So you don't have to put a lot of efforts. You don't have to put a lot of efforts. You just have to focus on the very simple thing. You just have to focus on very simple thing. That how to calculate a value and how to apply Lagrange's mean value theorem. For example, let us take a question. Sir, in mean value theorem, they haven't mentioned Rolle's of mean. You have to find out that whether you will apply the Rolle's mean value theorem or the Lagrange's mean value theorem. If the 2 point f of, in the mean value theorem, f of b minus f of a is equal to b minus a into f dash c. So this is Lagrange's mean value theorem. Determine c lying between a and b if f of x is given by this term, that is x into x minus 1 into x minus 2, x into x minus 1 into x minus 2. Yes sir, no issues in that. And the range is a is equal to 0, b is equal to 1 by 2. First we need to calculate the value of a. So if you put x is equal to a, f of a is equal to 0. Okay. If you try to calculate if you try to differentiate it up, you will differentiate it up and put the value of b. If you differentiate it and still again put the value of a, f of a is 0, f dash a is also 0. Okay. So f dash x is 3x square minus 6x plus 2. You differentiate it. Okay, when you differentiate this function, you will get the value 3x square minus 6x plus 2. You replace x with c, so you will be having an equation 3c square minus 6c plus 2. Now it is very simple. F dash c, you know what is the value of f dash c. F dash c is nothing but f of b minus f of a divided by b minus. This is what f dash c is. What is the value of function at 1 by 2? So this will be equal to, this is this is not f dash a, this is f of b. This is x is 1 by 2, 1 by 2 minus 1 is minus 1 by 2, 1 by 2 minus 2 is minus 3. So f of b is 3 by 8, f of a is 0 divided by b minus a, that is 1 by 2 minus 0. This is the value of f dash c, and this is nothing but 3 by 8 divided 3 by 4. Now you know the equation that 3c square minus 6c plus 2 is equal to f dash c, which is nothing but 3 by 4. Can you solve it for c? We'll try to solve it for c, not a very big deal. So this is nothing but this is 3 by 4 na. 3 by 4 na. So you solve it up. This will be equal to into 4 by 3. You multiply into 4 by 3. So this is equal to 3 into 3c square minus 6c plus 2 minus 3 by 4 is equal to 0. 8 by 8 minus 3, 5 by 4. So this will be equal to 5 by 4. 3c square minus 6c plus 5 by 4 is equal to 0, or 12c square minus 24c plus 5 is equal to 0. You try to solve this equation. So it will be equal to, if I actually go by factorization, so 12 into 5 is 60. 60 can be written as 10 into 6. 60 can be written as 12 into 5. 60 can be written as 15 into 4. 60 can be written as 20 into 3 as well. And 60 can be written as ठीक है, अब मुझे नहीं आ रहा है तो मैं डायरेक्टली उसको ऐसा सॉल्व करूँगा. C is equal to minus B. ठीक है, like the general formula for solving quadratic equation, minus B plus minus root over B square. 24 का square is 576 minus 4AC. So AC is 20 and 4 is 60, 240 divided by 24. So this will be nothing but 24 plus minus 240. आप इसमें से माइनस कीजिए. इफ यू सब्सट्रैक्ट 576 is 376 and it is 336 divided by 24. This will be equal to 24 plus minus 336, the root of something. I'll just check back that ये काय का root है. I'll check that ये काय का root है. So C का value somewhere around, you solve this equation, C का value comes out to be 1 plus minus 0.764. Now I have already told you, now there are two values of C. Which value will you will select? The value that is lying within this range, because the mean value theorem says that the value that is lying between 0 and 1 and 2, we are finding that value. So if it is 1.7, if it is 1 minus 0.764, so this will be equal to what? See, very simple. This will be equal to 1.764 slash it will be equal to 0.236. But this value is not in our range, so we will not consider this value. The only value we are going to consider is 0.236 is 0.236. I hope you have got the value how you apply Lagrange's mean value theorem. So we have the like previous part we have discussed role mean value theorem and its numerical. Here we have discussed Lagrange's mean value theorem and its numerical. I'll just give you a brief idea about how to go about it again. ठीक है. Step 1, calculate f of a, okay, f of b, and then calculate f dash c. This is nothing but f of b minus f of a divided by b minus a, and this is nothing but equal to f dash of x when x is equal to c. You differentiate the function and you put x is equal to c. So you will be having a relation and you will be having an equation in C. You solve that equation, you will get the value of C. Okay, but this is applicable only for Lagrange's mean value theorem. When it comes to Rolle's mean value theorem, f dash c directly reduces to 0. Okay, so we have seen the Lagrange's mean value theorem and how you solve questions related to Lagrange's mean value theorem. Okay, so now we are going to discuss about the Cauchy's mean value theorem. Now, till now we are considering only one function, but suppose there are two functions and we need to find the relation between the two. Or rather you can say, suppose this is your graph. Yellow color one is your curve, and this your curve is lying between the two curves. Now till now we were making it lie between a constant value, that is in the constant range a to b. Okay, now in this case this function is lying between f of x and g of x. Is it clear? This function is lying between f of x and g of x. That's it. So this Cauchy's mean value theorem we will discuss. We'll solve the question related to Cauchy's mean value theorem. That's not a very big deal. But the important part is, very important part is, you should understand what is the difference between all the mean value theorems. In Cauchy's mean value theorem, you have two functions, f of x and g of x. They both should be continuous in a and b. F dash x and g dash x should exist in a and b, and g dash x is not equal to 0 for any value of x in a and b. That is, it is not cutting the curve. There exists a value c in a and b such that f of b minus f of a divided by g of b minus g of a is equal to f dash c by g dash c. तो हमने दो Lagrange's मीन वैल्यू थ्योरम को डिवाइड कर दिया है. We have divided two separate curves Lagrange's mean value theorem. That's it. This is what Cauchy's mean value theorem says. Suppose there are two curves and we need to prove the mean value theorem between those curves, and the relation between both the curves is given that both of them are continuous independently. Both the differential of both the functions exist between a and b, and g dash x is not equal to 0 for any value. Okay, so that is why you apply this. So if we try to solve a question, we'll try to solve a question related to Cauchy's mean, because with question you will be able to understand the topic in a better way. We assume that you basically have a basic knowledge of calculus till now. Okay, because now it won't be possible for me to discuss very small things in every lecture, because these lectures are very short. They are like 10 to 15 minutes lecture. We don't want to waste your time, so that is why we have made it very simple. Chalo. The function is given as f of x is x to the power 4 and g of x is x square. You need to find the value of c such that these functions follow Cauchy's mean value theorem in the interval 1 to 2. So you have been given with a problem c such that this function follows Cauchy mean value theorem in 1 to 2. So you directly know that you calculate f dash x, this is 3x cube. You calculate g dash x, this is 2x. And if you calculate the value of f dash of c, this will be 3c cube, and g dash of c, this will be equal to 2c. And now what is the value of f of 1? F of 1 is 1, f of 2 is 2 to the power 4 is 16, g of 1 is 1, and g of 2 is 2 to the power 2 is 4. Now you know if you need to apply Cauchy's mean value theorem, so this is f of b minus f of a, 16 minus 1 divided by 4 minus 1, that is g of b minus g of 2 minus g of 1 is equal to f dash c, that is 3c cube divided by 2c. So this is equal to 15 by 3 is equal to 3c square by 2. Simple. So this is equal to c square is equal to 30 by 9, or you can say 10 by 3 c. Now c square. Now the value of c can be plus minus root over 10 by 3, plus minus root over 10 by 3, but you need to check that which value is actually lying in between. Which value is lying in between? So out of the two values, the value that we need to accept is plus root over 10 by 3, because minus root over 10 by 3 is not even lying in this range. So an option will be given. So you will see, if such option is given in the examination, you will be confused that like which c value should I choose. The question is wrong. No, the question is not wrong. The question is very much appropriate, because you need to find out the actual value of c that is lying within that range. So I hope Cauchy's mean value theorem is clear to you. Lagrange's mean value theorem is clear to you. Lagrange's mean value theorem is clear to you, and Rolle's mean value theorem is clear to you. This is very simple thing and very direct thing. I don't think that you would be having any issue related to Cauchy's value theorem. Now we'll move to, in the next part, we'll move to basically Taylor series, which is in general mean value theorem, a very generic form of mean value theorem. Okay, Taylor series in the next part. So the next topic that we are going to discuss today is the Taylor series. Now sir, what do you mean by Taylor series? How it is different? from other things. So now two important topics we need to discuss. One is the Taylor series and the second one is the Maclaurin series, which is again a specific case of Taylor series. A specific case of Taylor series. Now Taylor series is basically if the value of the function, if we need to calculate the value of the function at a, so we are actually expanding the function around a, expanding around a. So now what happens, suppose I need to calculate the value of sine 63 degree, sine 63 degree. Now how will you calculate? You don't have calculator, so how will you calculate it? So basically you will expand this function around 63, expand this function around 63 using Taylor series, and then you will get the value of 60. Sine 60 is what? So let us take to the formal journey. If f of x and its n minus derivatives are continuous in a and a plus h, that is a small value beyond a, and f dash f to the power n, like you can say the nth derivative of f of x exists for every value of x in the range a to a plus h, then there is at least one number theta such that, very very important, f of a plus h you need to calculate. Okay, you have the value of f of a, so we have the, so if you need to calculate sine 63, so then this can be written as sine 60 plus 3. So now you have the value of sine 60. So you calculate the value of f of a, that is sine 60, h, that is the difference you are having, into f dash of a, then h square by 2 factorial f double dash a, and the last term will be h to the power h to the power n divided by nth factorial, and nth derivatives of f of a plus theta h is equal to 1 into 1 is clear. This is what you mean as Taylor's theorem, and the remainder, this is nothing but a remainder, this is remainder, so this is known as Lagrange's remainder, and it is very very important question from exam. If they can directly ask for 2 marks, that what is the remainder in the Taylor's expansion for this function, what is the remainder in the Taylor's expansion for this function, and that is why it is very very important for you to understand that what is the value of remainder. So if you try to calculate the value of remainder, it is h to the power n divided by n factorial nth derivative of function at a plus theta h. Sir, everything is fine, we got that you are trying to calculate a value from a known value, that's it. So if I know the value of sine 60, we'll try to calculate the value of sine 60.5, 60.6, 61, 60. We cannot have sine 70 degree from this, because the h should be, h is almost 0, it is very very small. So till 1 degree to like 1 degree, 2 degree or 3 degree we consider, so h is quite small. Okay, so what is the purpose of Taylor series? Taylor series is just finding the values from the known values. Is it clear? So physical significance of Taylor series is calculating the values using derivatives. Okay sir, I got an idea, I got the feeling, but I'm not that clear. So let us solve a question for more clarity. This is Taylor's theorem. Okay, I'll give you an idea. If f of x is equal to log 1 plus x, using Maclaurin की जगह Taylor कर लीजिए. अभी आप देखो, the question is of Maclaurin only, but it doesn't matter. Taylor and Maclaurin are both same. Taylor is having like a generic case, and when you put x is equal to 0, that you don't have to worry, that we will discuss in the Maclaurin theorem. Just have to focus that there is a theta between 0 to 1, and log of 1 plus x is x minus x square plus x cube divided by 3, 1 plus theta x to the power 3. You need to deduce that 1 plus x is smaller than x minus x square by 2 plus x cube by 3 for all the value of x is equal to 0. First you need to calculate the value of the function. The value of the function will be somewhere around. Now you are actually see, I told you now, when a is equal to 0, the Taylor equation goes to Maclaurin equation theorem, that's it. So we are putting a is equal to 0 only, because we need to calculate that only. So f of x is f of 0, x into f dash 0, x square by 2 factorial into f double dash 0, x cube by 3 factorial into f triple dash theta x. Okay, so somewhere around you solve this question and you got f of x is equal to log of 1 plus x. So f of x is equal to 0, f of 0 is equal to 0, f dash x is equal to 1 upon 1 plus x, so f dash of 0 is 1, f double dash of x is minus 1 upon 1 plus x square, which is f double dash of 0 is 1, f triple dash of x is 2 by 1 plus x the whole cube, and f multiple derivative, it is f triple dash of theta x is equal to 2 upon 1 plus theta x whole cube. You substitute the value here. As soon as you substitute the value here, f dash in the Taylor series, you will fill the value in Taylor series, you will get the equation in this form. You will get the equation in this form. In Taylor series, when you will put, you will get the equation in this term. Now you understand this thing, that 1 plus theta x the whole cube is greater than 1, that is 1 upon theta x the whole cube is less than 1. Okay, and when you try to solve, you know that this value will be greater than 0 and this value is less than 1. So you shift all the values to the right and you get the answer. I don't think that this is a, see, if you are trying to understand Taylor series for the first time, I won't recommend that you will be able to solve. When you solve 4, 5, 7, 10 questions from Taylor series, then it becomes very important, very important. Then it becomes very important. Is it clear to all of you? I don't think that this is a problem or this is something important, like not understood, like something which goes beyond your head. Why we are using Taylor series? To get a value, to compute a value from the known values of the related standard results. Okay, and how you do that? Any value can be expressed in term of f of a plus h, and there is a whole expansion. That whole expansion you need to remember. Now in our case also, and there is a formula for remainder as well, so you need to calculate the remainder as well. But when you put all the values in equation, you will get to know that how it is moving and how the things are going on in here and there. Is it clear? So that is why a simple inequality question is there. I would recommend please mark star and solve at least 10 inequality question to get a better idea or to get a better result. Okay. So I hope you have enjoyed today's lecture. You have understood a lot, and if you are having any doubt, the slides to these lectures will be available on the Telegram channel Maths A Confidence. Apart from that, there is a very exciting project that is being carried out by Unacademy, which is known as All India Mock Test. Sir, what is this All India Mock Test? So All India Mock Test is being conducted for GATE 2023, where a exam will be conducted just like GATE and ESE, so that you will, it is like a simulator test, that is, you will have an experience of that how you will feel while giving the real-time exam. So that is why it is being conducted on a specified date. You cannot attempt it at any point of time. So it is December 4, December 18, 2022, January 8, January 15, 2023, 22nd January 2023, and 29 January 2023. In this, you will get to know your All India rank. You will also be practicing questions that are curated by top educators, and apart from that, you will also get a detailed performance report and along with that video solutions. So what are you waiting for? Just enroll it for free right now using the code Prakhar21, PRAKHAR21, Prakhar21. You can enroll it for absolutely free by giving a call to the below number. Apart from that, there are other exciting things that are carried on by Unacademy, and such as Udan batch. So from 24th of November 2022, an Udan batch is started with the top-notch faculties for Unacademy, GATE Computer Science. And in this, for this you have to join Unacademy Plus subscription. And now there are two types of subscription. One is the Plus subscription, and other one is the Iconic into it. And if you want to join Unacademy Plus or Iconic, you can use my code RAAH Prakhar20. Okay, and apart from that, you can also order your physical notes to your doorstep. What is the process? First, you need to go to the self-study tab in your Unacademy learning app. You need to fill in your order, your delivery or address and the other details. You have to confirm your details, and as soon as your order is processed, a message sent to your registered email ID, and very soon the product will be delivered to your home address. Apart from that, many people struggle with what do you mean by Iconic and the Plus subscription. So Plus subscription is an advanced form of Unacademy where special facilities are given to the students, like top educators teach them, they'll give the PDFs, that is the digital notes, and yes, they are also eligible for the test series. But since you are preparing alone, I would recommend that you should go for iconic subjects, because see, when you go out and prepare with other students, the physical format, you don't need someone to help you out. But when you are preparing alone at your home, you need someone to push you when you are low, you need someone to discuss things. So that is why this is the best feature of iconic, that is one-on-one live mentorship is given. Along with that, printed notes will be delivered to your home address. Customized doubt solving feature is there, and a strategy and a study planner will be made for you. You don't feel alone. Apart from that, interactive open house sessions are also conducted to boost you up, to get you more clarity about the examination, about the colleges that you will be getting after this. Apart from this thing, the prices are flexible. That is, the prices for 24 months is 59,708 for plus subscription, and it is 73,000 for iconic subscription. For 24 months you are getting 13,000 extra. You have to pay just 13,000 extra for iconic subscription, in which for 2 years you will be getting a companion printed note. So why you are waiting for? What you are actually waiting for? It is, even you can say, less than 600 rupees around a month, that we usually spend here and there. So if you want to join an Academy Plus or iconic subscription, you can use my code Prakhar21, and you will to get the maximum discount. And it depends upon the facilities that are available at this particular moment of time when you are trying to solve it. Like, you can get a very heavy amount of like discount, because there are multiple times there are price drops as well. Okay, so this is again one very important thing. And if you think this amount is quite huge, so you can opt for no cost EMI or 0% loan on interest, so that you don't have to pay at once. You can start with as low as 22,239 rupees per month, which is even less than school fees of some you can say some school, that is some like a lot of schools. So you can get the approval in 2 hours, minimal paperwork. So this is not a very like challenging thing. The third thing we are having is Unacademy Lite. So for 12 months you have to pay 1,490. For 24 months you have to pay 2,499. Again, if you use the code Prakhar21, you would be getting a 10% flat discount. Apart from that, here in this subscription you will be getting the questions created by top educator. 60 plus tests are available for all branches. Doubt solving sessions are there with expert. Detailed results are there, so you will enjoy it. Okay, so I hope that you have enjoyed today's lecture. I hope you have got the brief idea about what we are doing right now. We are promoting the quality education. Hope you have enjoyed today's lecture. Thank you.